Hello my dears. So we are going to discuss about the transient stability analysis by increasing steam input suddenly and a concept of equal area criteria now. So in the last classes we discussed about a hint of what is meant by equal area criteria and all. So now we are giving an input like a change in input, like we are increasing the steam input so that we are increasing the mechanical power, and see what happened to the rotor angle and what is that equal area criteria is applied there, or how can we apply that equal area criteria there. Okay, let's see my dears. So initially the machine is operating at a stable rotor angle del 0. So at that time we can say that the shaft input PS0 will be equal to P0. PS0 will be equal to P0. That means there will not be what any acceleration or deceleration. The machine is smoothly running. So suddenly I am increasing my fuel input to the mechanical system so that the mechanical power will be increased. This PS1 is nothing but the new mechanical power. Whenever we are increasing the mechanical power of a system, what happens? It's a rotor angle, I mean mechanical power of an alternator. We are increasing the mechanical power of an alternator. The shaft, I mean the rotor angle will increase. So the rotor angle will increase from del 0 to del 1. So del 1 is nothing but at point P. The rotor angle is nothing but del 1. Okay, the rotor angle is nothing but del 1. So we can analyze these things with respect to three regions, that is nothing but during AB. Okay, during A to B. So what happens during A to B? So during A to B, the rotor angle is increased to del 1. So that what happens if you are increasing the rotor angle? How can we increase the rotor angle? We increase the mechanical power input now. So here at point A, there will not be any accelerating power because PS minus P is the acceleration power, or PM minus P is the accelerating power now. M into d square del by dt square equal to PM minus P now. So that PM minus P is called the accelerating power. Now at a point or up to at point A there will not be any accelerating power. The machine is running very smoothly. So suddenly we increased the fuel input so that the machine rotor angle will increase. So at a point B, my dear, at a point B, what happened? I will say you during AB what? During AB we increased fuel input. So the rotor angle increases. Rotor angle what, my dear? Increases to del 1. The rotor angle increases to del 1. So at P, so what I can say that increases to del 1 means, so now there will be an accelerating power PA, because PM minus PE is called PA, and that acceleration power PA will be greater than 0 because PM will be higher because we are increasing what? The rotor angle. So at a point B, so the machine will accelerate. That is very, very important. So during the trajectory AB, the machine will be accelerate. Because we increase the fuel input. And at point B, okay, so suppose we are increasing the speed, and let us assume, my dear, here it is, suppose it is running, say an example, 1500 rpm, because we increase the speed now, and here it is nothing but its synchronous speed is nothing but 1000 rpm. Let's take an example. Okay, so at a point B, how can we say that? At a point B, what? This delta 0 to del 1 increased. If you are increasing the rotor angle, then the power output will be what, my dear? EV divided by X into sine delta 1. So sine delta 1 also increased. That means at a point B, there will not be any sudden equal of mechanical and electrical power happens, first mechanical power we increased and back the rotor angle increased, and due to the effect of sine delta 1, because rotor angle increased from here, it was what, my dear, EV by x into sine del 0. So this del 0 is small now, but now the del 0 del 1 is increased now with respect to del 0. So power also was increased. So at a point B, now this PS1 will be equal to nu P1, because at del 1 the power is increased, the power is boosted, so that at a point B, what, EV divided by x into sine delta 1 will happen and power will be increased. So I can say that PM minus PA now, or PM minus PE, which is equal to PA, equal to 0. That means there will not be any acceleration. There will not be any acceleration at a point B. So initially there was accelerated, A to B it was accelerated, but when reaching the point B, or whenever the electrical and mechanical power equal, at that time there will not be any acceleration, so that P is equal to 0. But what happened to this d del by dt now? D del by dt is nothing but changing rotor angle with respect to time. D del by dt is nothing but minus omega s, because changing angle with respect to time is always gives the angular velocity. So omega minus omega s will be d del by dt. Our omega is nothing but, my dear, now 1500. Omega s is nothing but, my dear, initially 1000. There will not be any change in the synchronous speed now. So 500 rpm. This 500 rpm is greater than 0 now. That means d del by dt now greater than 0. If d del by dt is greater than 0, what happened? If d del by dt greater than 0 means changing rotor angle with respect to time is high or C, not equal to 0. Not equal to 0 means there will be a change in rotor angle with respect to time, and that in increasing manner. That is the meaning of d delta by dt greater than 0 or positive. Is it clear? So d delta by dt equal to 0 means the rotor angle will further increases. That is the meaning. At a point B also the rotor angle is increasing. That is the indirect meaning of d delta by dt greater than 0 at a point B. Is it clear? So what happened? The rotor angle further increases from del 1 to del 2. The further increases from del 1 to del 2. Okay, so during BC, I hope you clear it. Okay, so during BC, so AB it was acceleration, B there is no acceleration or deceleration, and during BC let's see. So during BC what happened, my dear? If you take any point during this BC trajectory, say this point, here it is what, my dear? The electrical power, this electrical power, let be PE2, will be always greater than the mechanical power, right? Because this is the horizontal line, this is the mechanical power maximum we applied. We drive the alternator at maximum power and continuously we are rotating 1500 rpm. Not more than that. But any point after B, you can see that this is the electrical power, P. This power is always greater than the shaft power. That means electrical power is always greater than the shaft power after any point B. So now we can say that PM, so during BC at any point after B, the mechanical power less than electrical power. Or I can say that PM minus PE, which is nothing but PA, okay, which is nothing but PA. PE greater than PM means PA less than 0. That means deceleration. Very, very important, my dear. Very, very important. So Pm minus Pe will be now deceleration. Because Pe greater than Pm, it will be a negative quantity. Pe less than 0 will happen. Pa less than 0 means it is nothing but, my dear, deceleration, right? Pa greater than 0 means acceleration now. So similarly, Pa greater than less than 0 is nothing but deceleration. And what happens to this d del by dt now? D del by dt is nothing but minus omega s. Omega minus omega s. Omega minus omega s, is there any change? Omega is again 1500, it is again 1000. So again is equal to 500. So which is equal to 0. Which means during BC also again the rotor angle increasing, goes on increasing. Okay, that means rotor angle still increases from del 1 to del 2. So any point if you see here, the rotor angle is actually continuously, it is increasing from that del 1 to new value, del 1 to new, simply del 2, maximum del 2 now. And at the point C, what happened? At the point C. So at the point C, what is happening? So at the point C, my dear, at the point C, again it comes like this, it comes like it, because this region is a deceleration. This region is a deceleration. During BC is a deceleration. So it is continuously decelerating. The power is reducing. At the point C, PS1, again that mechanical power and electrical power coincide each other. So at the point C, I can say that PM minus PE, which is equal to PA, equal to 0. That means there is no acceleration. There is no acceleration or deceleration, anything. There is no acceleration or deceleration. There is no acceleration or deceleration. Or what about the d del by dt now? D del by dt is nothing but, my dear, at this point now, at point C, what was the importance of point C? D del by dt, the electrical power will be same as that of the mechanical power, right? Electrical power will be same as that of the mechanical power. That means at point C, yes, at point C, what happened? This will be 1500. Here we increase the mechanical input, right? So it is continuously decelerating. It continuously decelerate. It decelerated to what? This PS1, the PS1 is what? 1500 RPM. So 1500 minus 1500 reaches and is eventually 0. D del by dt is equal to 0 means what? What I can say? There will not be any further increasing rotor angle. That is, no further increase in rotor angle. That's all. So finally, the rotor angle settles here at point C. There is no further increase in rotor angle. Okay. So this is actually what, my dear. So the area, this area should be equal to this area. If these two areas are equal, then we can say that means, suppose this is A1 and this is A2. For stability, I can write here. For stable operation, A1 will be equal to A2. That is simply called the equal area criteria. Equal area criteria, because this area and this area, pictorially it is not equal, but in practical case these two areas should be equal. That is called the equal area criteria if the system is stable. If these two areas are not equal, then this will not be a stable system. This will not be a stable system. So this del 1 to del 2 movement now it is not actually happened quickly. It is actually happened after very what? High oscillations, very high, I mean very what time oscillation it is happening for few seconds or something. Na? As soon as we reduce the oscillation, then that will be a good system. If the oscillations are very less, means it will be good system. Otherwise, it will be bad system, right? So this happening not quickly, so quickly, but it happened after very oscillation. The final value now, you see, it is not quickly attainable. It's not quickly attained. Okay. See, my dear. So. Listen. So I can say that A to B, simply A to B acceleration, B to C deceleration, again A to B acceleration, B to C deceleration, C to B again deceleration, and B to A again acceleration, again A to B again acceleration. This process will be continuous. This rotor angle change will be continuously happen. It oscillate about a rotor angle. Suddenly the rotor angle, new rotor angle del 1 will not be attainable, or rotor angle del 2 will not be attainable. It's actually oscillating. So whenever the mechanical power is higher than the electrical power, there will be acceleration. Whenever the electrical power region, this is all region is containing the electrical power is higher than the mechanical power, that region will be PA less than 0 region. So that is called the decelerating region. So B to C is always decelerating and A to B is always accelerating. So it move from A to B, it will not settle there. It move from B to C, it will not settle there. It move from C to B, it will not settle there. It move from B to A again, it will not settle there. It moved A to B, B to A. After few cycles, this process will happen. A to B, B to C, C to B. Here na? A B, B C, C B, B A B, B C, C B, B A B, B C, C B, B A. This process will continue for 2-3 cycles or 4-5 cycles. After some time, it will settle to a new rotor angle or maximum del 2. Okay, actually new rotor angle is nothing but del 1, not del 2. Maximum it can move up to del 2. That is the meaning. So I can say that maximum rotor angle to which the oscillation extends equal to del 2. It equal to del 2. I already told you maximum angle by which we can increasing the steam input is nothing but 90 degree. Maximum 90 degree up to this del 1 can be extended up to this one. Maximum here it can be del 1, but after this it will be unstable surely, because whenever moving after this one, the point C will be below this typical value. So that will be an unstable region, because if you move this point below this one, this region is nothing but the what? Electrical input will be less than the mechanical input, right? So this is mechanical, this is electrical now. So it will accelerate to point C, that's all. It will not decelerate further. So maximum up to point C. So maximum rotor angle by which we can increasing the steam input is nothing but, my dear, del 1. Del 1 is nothing but at maximum 90 degree you can increase. Maximum rotor angle to which the system is oscillated is nothing but up to del 2 it can oscillate. That's all. So that's all about the equilibrium criteria. I know it's very difficult to understand, watch this video 2-3 times, okay. So you will clear, okay, definitely will idea will be get, and I am sure that this will not be asked for normal level of examination. If the examination is very high, it's very tough, then also some objective question will be asked, not even the problems and all. No one will ask, okay. So we have to complete the syllabus now. For electrical inspectorate examination syllabus now, large syllabus, you can see that there is a portion is there, steady state, transient stability and equal area criteria and all now. So that's all about the criteria, okay. So thank you so much.